So, Craig, we'll do notes first. We'll go back to page 2, I think, in the book, and we'll just read some stuff through together. And then we'll dig into homework questions at the tail end. I think you'll find today a little bit more to your liking. I think yesterday you were trying to awaken a sleepier part of your brain than what today will be. So I'm on page 2, just reading you some stuff they have in the book to remind you of some words. Number 1, they talk about ordered pairs. I would think you would remember ordered pairs. Like if I said to you, find the location 3, 4. That's an ordered pair. Where would you go to find that spot?
Over 3, up 4.
Over 3 to the right, and then up 4. If I went like that, now you're not headed right, you're headed
Left 3.
and if I do that, you're now headed
Down.
down. Okay, so that's an ordered pair, that's still a thing. The first number represents
X.
X, and the second one,
Y.
Y. These numbers individually are called, this is the X coordinate, and that's the Y coordinate. So that's in there. Relation is not a word that we've used very often, if at all, maybe in Algebra 2 a couple times, but a relation is just a bunch of ordered pairs. So if I had a bunch of ordered pairs together, that makes a relation. Graph, we talked a little bit about graphing yesterday. A graph is just a picture of what we have for our ordered pairs. Domain is a word we had in Algebra 2 a little bit, and they're going to have that word in calculus today. The domain has to do with the x's that go in. That's not a super giant important word for you to know, but it's a word. The range or the y's that come out. A function is something where you take one value, you put it in, and you get out another, basically, is what they're describing there. I'll go over and actually use my calculus note section. If our function was x squared, and 2 was part of the domain, when 2 goes in, out comes, and we're squaring, 2 goes in, 4 comes out. So if 2 is in the domain, 4 is part of the range. 4 could also be part of the domain. If 4 goes in, 16 comes out as part of the range. If 1 was part of the domain, the range would be still 1, because 1 squared is 1. But anything that we can put in would be part of the domain. Anything you might get out would be part of the range. Could 9 be in the range? Could you get 9 out?
Yes.
If you put
3.
3 in. Could negative 9 be part of the range?
No.
No. Why?
Because a negative times a negative is a positive.
Yeah, there's no way you can square any number and get a negative out. Could 0 be part of the range? Yes. If you put 0 in. Okay, but those are not super important words to our homework life, but they're words, okay? Maybe it's an SAT use kind of word, I don't know. But the domain is stuff that goes in, the range is stuff that comes out, the function is basically the math formula that does stuff to those numbers to probably change it. Page 3 is where we need to know some things. So on page 3, they have some different kinds of functions described to us. There's 7 of them. And conveniently over here, there are 7 options, 1 of each type. So part of your homework is going to be to classify which type is this, and part of the homework is going to be to just start doing math again, like 3 squared is 9, and the stuff we were just doing a minute ago. So choice 1 on the list on page 3 is a thing called a linear function. You might remember, hopefully remember, the equation y equals mx plus b. Y equals mx plus b was a thing called slope-intercept form, where the m represented the slope, and the b represented a thing called the y-intercept. That's where we would cross the y-axis. If this sounds like you've heard this recently, it's because yesterday in class I had this exact same conversation with the calculus people. So if you didn't completely tune us out, like that's all stuff we were talking So linear is something where it's y equals, there's some number next to an x, and then there's some other number adding or subtracting at the end of that. So out of 1 through 7, which one of those is my linear function?
6.
6. Because 6 fits the format of y equals mx plus b. The slope is 6, the y-intercept is 7, that is a linear function. It's called linear because if we graphed it, it would make a
Line.
line. And they drew a picture of a line there for us in number 1. Number 2, there's a thing called direct variation. Direct variation is just y equals mx. Skip the b. Which means the intercept, I guess, is still invisibly there. What number would it be? 0. So therefore, the picture they drew you is still a line, but it has to touch the origin because of the missing number. So if we go to look for direct variation on our list, that would be number 2. Because that's y equals mx. That is our direct variation. 3 is quadratic. That's a word we had a good bit in algebra 2. That should feel pretty familiar. We had a quadratic formula, that negative b plus or minus root b squared minus 4ac all over 4a, that guy. The word quadratic came up a good bit. So quadratic means it has an x squared, and probably has x's, and probably has a number at the end. So if we go look, and if you graph x squared stuff, you might remember from algebra 2, it's usually U-shaped stuff. We graphed a lot of U-shaped stuff from our squares at times in algebra 2 world. Quadratic would be 7. Because it has an x squared, it has an x, it has a number. Higher degree variation is kind of like number 2. Okay, what's the difference between number 4 for higher degree variation compared to number 2? There's powers involved. So there's some number at the beginning, like 2 had a number before the x, but the x has to have a power on it. So where is our higher degree variation?
1.
It is 1. 1 is higher degree variation. They're almost the same, but that one had a power. 5 is exponential. Looking at 5's equations they wrote a couple options. What is 5's deal? What do you think you could spot that makes exponential be recognizable as exponential? Or on the board, 3, 4, or 5. Which one is the exponential?
3.
3 is correct. How is 3 unlike everything else on the board?
As an x, as an exponent.
The variable is an exponent. A lot of these had exponents, but this is the only one that the variable is the exponent. That's exponential. Rational algebraic, they say there's a polynomial on top of a polynomial. A polynomial is basically any sized algebra thing. If I look at this is a certain type of polynomial. Anybody know its name?
Monomial.
Say again?
Monomial.
That is a monomial. If I look at this one, it is a binomial. Trinomial. But they're all polynomials, any size. So somewhere on this board, I have one polynomial on top of another polynomial. Which one does that more seem to apply to, 4 or 5?
5.
I'd say more 5. You could argue for 4, but we have to use all 7 choices, so we better leave that one for a minute. 7 is obviously inverse because we ran out of choices. Inverse has a number on the top. Whenever they have the A's, B's, C's, those are numbers. Whenever they have an X, that is locked in to be the actual variable X. But 7, the formulas they wrote, it's a number on top of an X or any power of X. Question about classifying what type is what type? So we'll turn a page to page 4, and I'll do homework problem number 1 for free. And then we'll wrap that up and we'll look at whatever questions people brought about yesterday's homework. So looking at number 1, part A says name the function. What type is it? So they have the problem y equals 2x plus 3. Out of the 7 types we just did, what type is that?
Linear.
It is linear. So anybody bothered by recognizing what type it is conceivably as you go through? There's 14 of them, so I have to assume there's probably 2 of each kind. So there's 7 options, there's 14 problems. I don't think that's going to be X. Questions about that? Then they say, B, calculate some Y's if we give you some X's. What was the other fancier name for the Y's? That we strayed through our calculus lesson? Range. The X's were called the domain. Okay, but they want us to find some Y's for some given X's, and they do different numbers for every problem. I would suggest you just make yourself a little XY table like we've done in the past a lot. So we're going to go on this problem, the X's are -4, -2, 0, 2, and 4. I would encourage you, if you can, just do the math in your head to get your head going again. But on something like, I don't know, number 6, you might not want to do -16 times 5 squared plus 80 times 5 plus 3 in your mind. You might not want to do that, and I'm fine with that. If you need to use your machine, use your machine. But if you can avoid using the machine, I think it would be good to wake your brain back up a little bit. But it's your life, you can judge that as you wish. But if we do 2 times -4, we're thinking at that point, -8, add 3.
-5.
Somebody other than Amelia, we go 2 times -2.
-4.
-4, add the 3.
-1.
-1. A new voice, 2 times 0, add 3.
3.
Another new voice, 2 times the 2, add 3.
7.
2 times the 4, add 3. 1. So that's part B, make the table. Question about make a table? Part C, they want you to make a graph on graph paper. I don't care about graph paper. You don't need to do graph paper. You can do your own little sketchy graphs. Depending on how the numbers go, they tell you, and I'm telling you, it's not necessary to use the same scale for both axes. So since this was only using numbers between -4 and 4, I just did 1 space per. I didn't feel like I needed to count by 2s. I didn't mind counting single spaces. But when I went to go do this one, I didn't feel like making 11 marks. So I'm going to need you to show me, like you counted 1, 2, 3, 4, or 2, 4, 6, 8, 10, 12. Show me what you're counting by in some way, label those, and then we'll plot these points. So where was -4, -5? Up, down, left, right?
Left 4.
Left
Down
4.
5.
Down 5. So for 5, I would need to do like 2.5 of my marks. -2, -1 is there-ish. Where is 0, 3? Straight up 3. 2, 7, 4, 11. Like connect the dots. And since it was linear, it shouldn't be shocking to us. It's a line. If you want to make sure you're on the right track, I have 2 ways that we can make sure we did that. But there we are for that one. Let me show you some calculator stuff. We can keep recording this. It's fine. I'll get back into the screen in a minute. One way I can check my graph is turn it on's down here. Hit the y equals button that's up at the top. And I'm just going to type in this equation, 2x plus 3. So I'll hit the 2 button. I need to hit this button for x. It's diagonally away from your second button. So hit that, plus 3. And then hit the, and then hit the graph button. If it looks really weird, if it doesn't look like what ours look like, hit the zoom button and pick choice 6, which is standard. But you should get a window that basically looks like what we just got. So, works for you? That work for you?
Yep. I just.
Did it work?
Let's hope that.
Yep. I hit the end. I gave out. Okay, so here's another interesting feature of the calculator. If you're going to do the same kind of math over and over and over again, even though we were able to do this in our mind, let's act like we can't. So if we were going to go 2, punch with me, 2 times, the negative button is down by the decimal point, 4, plus 3, hit enter, and choose the top of negative 5. That doesn't seem that fancy yet. I understand that's about to get a little fancier. Anybody not to the point where you got the negative 5? When we go to do the next calculation, hit the second button and hit the entry button, which is down in the corner, and it brings you back the thing you just typed. See how it did an instant replay? Use your arrows to replace the 4 with the 2. Hit enter. I'd skip the 0 one personally if it were me, because the 2 one is more similar. So I'd go second entry. I'd use my arrows to go to where I had a negative 2. I will use the delete button to delete the negative. Hit enter, and I got my 7. To do the 4, I I could either go back to where the 2 was, or I could go back to the negative 4. Go ahead and flip with me, go second entry, second entry, second entry, second entry. It gives you an instant replay of like the 10 most recent things-ish that got punched, including probably stuff you haven't even punched. Like if this is a hand-me-down, it might scroll back into things that people were punching in March before we went on quarantine. Like it'll backtrack as far in its history as it could go. But you can get to a point where you have a calculation that's similar to what you did, and then just make that little change. You know, make a 4 in there, make a 0 in there. That isn't that fancy for that one. Okay, but for this problem, had you punched in 2 times 5 squared plus 3 times 5 plus 3, and then when they change 5 to 6, that's a nice feature. Because you've already got that all laid out, you just change the 5 to 6, and you can cruise through repeat calculations a lot faster. It's also kind of nice in case you get an answer you don't know, it was like, I didn't expect that. You can see what was there. And if you realize, oh, wait a minute, that needed to be a 7, not an 8, you can just bring the calculation back and change the one thing. You don't have to keep restarting over. So that's an interesting little thing with these. Questions on that? So, quick discussion on this. If I ask you to take negative 3 and square it, we already had that conversation. If we expected to do negative 3 and square it, what should the answer be in human knowledge?
9.
9. Positive 9. If you take your calculator right now and punch in negative 3 squared, it didn't do that. How do you work around that?
Just get rid of the negative.
Well, if you wanted to use your knowledge, you could do that, but if you insisted on punching in the negative, there's a way we can work around that as well. You could, but there's a better way to work around. It seems like your calculator's dumb and your calculator is not. When you punch this in, remind me of the order of operations.
Wait. Okay.
Parentheses. Exponents.
Multiply.
Tied with. Divide.
Division.
And subtract. The negative in front is what operation from that list? It is not.
Parentheses.
It is not.
Multiply, divide.
It is a multiply divide. Because really, this is like a multiplication by what number? If I go like that, what number did I just
Negative
multiply? I just multiplied by -1. Okay, so when you see this is a multiplication by -1. The power takes priority over a multiplication. Your calculator is smart. It is doing, if you ask it to do this, it is correctly doing it. You didn't ask right. If you want the -3 to be squared, how do you need to ask?
Do the negative 3 in parentheses.
You need to wrap that up. So if you're ever trying to take negatives to powers, you're responsible for wrapping that up to communicate to your machine. Because now the parentheses are taking priority and the power applies the way you want it to apply. So that's an important thing to know. On this homework, once you get around like 5-ish that starts to have powers, you're putting negatives in to do powers. You may need to do a little bit of parentheses action. Question on anything you see here from page 4 about what you're looking to do. So we can just sort of cut that and we'll talk